Hey there, future physicists. Ever touched a hot cup of coffee and thought, why doesn't it keep getting hotter forever? Well, that's the magic of thermal equilibrium at work. You see, when two objects are in contact, heat flows from the hotter one to the cooler one until they both reach the same temperature, and voila, we call that thermal equilibrium. Imagine you and your friend are fighting over the last slice of pizza. At first, it's all me, 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 but eventually, you both settle and share it evenly. That's how heat balances out. Now, the cool thing is, there's a scientific law behind it, the Zeroth Law of Thermodynamics, which says that if two systems are each in thermal equilibrium with a third system, they're in thermal equilibrium with each other. So, if you're touching a cold glass of ice water and a warm glass of coffee, they'll both eventually match temperatures with the air around them. It's a universal peace treaty for temperatures. Alright, let's dive a little deeper. Now, what exactly is temperature? Is it the same as heat? Not quite. Temperature is the measure of how fast the molecules in a substance are moving, and it's a measure of the average kinetic energy of particles. Heat, on the other hand, is just the energy that flows from something hotter to something cooler. Think of it like your phone's battery. The higher the temperature, the faster those molecules are moving, and that's why they say a battery heats up when you're using it, its energy flowing, or in this case, being wasted as heat. When heat flows, we can calculate it using the formula Q is equal to m*C delta T. Here, Q is the heat transferred, m is the mass, C is the specific heat, and delta T is the change in temperature. So, if your coffee goes from piping hot to lukewarm, that's the heat that's transferred, and you can track it with this formula. Now, let's talk about the Zeroth Law of Thermodynamics. Sounds fancy, right? But it's really just a statement about how we measure temperature. Imagine you've got three bodies, A, B, and C. If A and B are both at the same temperature, and B and C are at the same temperature, then guess what? A and C must be at the same temperature as well. It's like a big game of the friend of my friend is my friend. This law lets us build thermometers because it tells us that when two things are in thermal equilibrium, they're the same temperature. And that's exactly why thermometers work. They allow us to compare the temperature of something with a known substance that's already in thermal equilibrium. Let's make it practical. Ever wonder how refrigerators work? Or why your car's engine heats up? That's thermal equilibrium at work. In a refrigerator, heat flows from the inside, where it's colder, to the warmer surroundings outside. But the system is designed to keep transferring heat until everything cools down. In your car, the engine heats up during use, heat flows away until it balances out. Thermal equilibrium isn't just some scientific theory, it's something you deal with every day. Without it, we'd have no way of controlling or measuring temperature in systems like engines, homes, or even your kitchen. Alright, time for a real-world problem. Let's say we've got two bodies. Body A weighs 500 grams and is at 100 degrees Celsius, and body B weighs 300 grams and is at 30 degrees Celsius. They're in contact, and we want to find the final temperature. Here's the equation. M subscript A times C times the quantity T subscript 1 minus T subscript F equals M subscript B times C times the quantity T subscript F minus T subscript 2. Now, substitute the values. 500 times 4.18 times the quantity 100 minus T subscript F equals 300 times 4.18 times the quantity T subscript F minus 30. We simplify and solve for T subscript F, which turns out to be 60 degrees Celsius. So, after a while, both bodies will settle at 60 degrees Celsius. That's thermal equilibrium in action, where heat flows from the hotter body to the cooler one until they reach a common temperature. So, to wrap it all up, thermal equilibrium isn't just some boring term, it's how everything around us balances out. When two objects are in contact, they'll exchange heat until they reach the same temperature. Thanks to the Zeroth law, we can even measure temperature using thermometers, knowing that if two things are in equilibrium with each other, they're the same temperature. From your morning coffee to the way your car manages heat, thermal equilibrium is always at work, making sure everything's in balance. Keep this in mind next time you find yourself touching a cup of coffee. It's all about finding equilibrium.